News Conference. Good morning. Welcome again to Airventure 2012. I'm Dick Kapinski from EAA Communication staff. Our friends at Lycoming are once again with us. We're very happy to have them at Oshkosh exhibiting here and also talking about some of the developments of their products. Here to tell us more about that, Michael Kraft is with us from Lycoming. Michael, the microphone's yours.
Thanks, Dick. Okay, so first up, in front of the booth this year, you're going to see two aircraft. One is a Tecnam P-92 tail dragger, and the other is a Comet. Both of these are powered by the O233. Well, actually, the Comet is powered by a YAEI O233. This is an experimental aerobatic version of the 233 engine that was produced through our Thunderbolt side of it. These manufacturers, in addition to the two that we have on the front, we've got Kitfox, American Legend, Bushwhacker, Flying Circus, Zenith Zen Air, and Brumby Australia have all publicly announced plans to produce 233 powered aircraft, and there's several others that are doing that. So that engine moves to its next phase. ASTM compliance on the 233 was achieved late last year. We've continued the durability testing and qualification testing to move the TDO under the ASTM standard to $2,200. Once again, you have an ASTM conformance that is separate from an FAA type conformity or an FAA type certification. So we're independently doing the ASTM qualification work right now, and it's now moved up to $2,200. The electronic spark ignition system has been subjected to and passed all the environmental tests required by the ASTM standard, which in our read is the same thing that you do for Part 33 certification. With ASTM qualification and full rate production under our belts, we're moving towards FAA Part 33 certification of the engine in the next year. Some key details, which we've mentioned before, but worthwhile repeating. The engine has been approved for use on 91 AKI or gasoline. The dual electronic spark ignition system is a pretty major achievement, and I think it's a sleeper in terms of what the general aviation community might understand what that means. It's not only easier starting and smoother running, it's a major impact on life cycle costs. So you no longer have a $100 or $500 inspection as you would with the Magneto. There's no unscheduled maintenance for timing drift associated with the wear and mechanical components. The ESI unit has a variable timing for start and operation, which reduces your starter life. So your starter life is not, you see beneficial effects on starter life. So long term, expect to see that piece of the O233 technology migrate to our other engines. Once again, the ASTM and the FAA experimental versions are now fully transitioned to production. They can be purchased through the aircraft manufacturers that we mentioned or via our Thunderbolt engines product line. Next up is UL 100. So UL 100, let's coin the phrase there. Low octane avgas is already here. So there is low octane avgas being distributed. It's not at the 100 mile range. UL 100 is coming, and that's actually a good thing for a lot of reasons. Our position remains from Lycoming that the existing aircraft install base is our primary consideration in terms of rolling out the new unleaded fuel. At today's current production rates, we've got more than 100 years of aircraft out there to be supported and serviced with fuel. And no matter what new technology we throw out there, we still have to service and support those existing aircraft. So the UL 100 solution, we stand firmly behind. That has to be the target long term. It needs to be affordable. It needs to be deployable to the fleet and controlled in our process. There is no reason to doubt that we can't achieve this if we stay focused. For last year, I served on the FAA's unleaded avgas transition arm. It's hard to describe what an unprecedented step that was. You've never had in previous investigation the actual soup to nuts players involved in terms of from the innovators to the producers to the distributors to the regulatory agencies, that's plural, all captured in place. There never was a project plan which showed you which all the check boxes to check as you went to deploy the fuel. And the hardest thing about this is probably not the technology. The hardest thing about it is going to be actually ramping it up to full-scale production and global distribution. So a few years ago, I stated that we've got to stop loving the problem. Well, we did stop loving it. We moved to a different phase. There's a lot more hard work to do, okay, no matter how you slice it. We need continued FAA leadership, and we need funding to make it happen. We need to have it focused. So this year, my statement is, pretty much, team, you've got the playbook, you've got the game plan, it's time to execute. Remember that the game plan can change after the first play. The objective, however, which is to win, is not. And so maybe I'm channeling Vince Lombardi here a little bit because we're too close to Green Bay. But the fact is that we actually have a playbook. We know which boxes we need to check. We have a series of gates that tell us what the maturity is. Okay? We have some objectives, and we have a far better understanding of this because we had that integrated team working on it, and that's pretty unprecedented in terms of history. So there is a clear goal. Our opinion, Lycoming's opinion, is that it needs to be a UL 100 solution, mainly driven on the fact that we've got a very large installed base of aircraft that we need to continue to support. So it may seem contradictory that last week we also approved a broader range of engines on UL 91. The fact is that within the European community, they are now producing, they're refining, producing, distributing, and via EASA SIV have approved UL 91 for use on aircraft that the engines have been approved on. Our latest series of approvals last week now means that a very large installed base of aircraft, ranging from Piper Warriors to Archers to the Cessna 152, 172 Skyhawks, 182 Skylanes, Robinson R-22s, Robinson R-44 rated 1s, Diamond DA-40s, Diamond DA-42 All-360s. There's a very long list of aircraft now under the EU are approved for use on UL 91. So it is flowing in Europe. It's flowing in an increasing number of FBOs. EASA guidance approved the aircraft with their engine approval. Now, does this approval mean, does Lycoming's extension UL 91 mean that we're endorsing UL 91 as a solution? No. That is not a fact. We are not endorsing UL 91 as a long-term solution for the fleet. Okay. Is this a significant development for general aviation? Absolutely. Okay. This is very significant. So let me connect the dots over here. First point. The ASTM D7547 UL 91 specification actually arose out of a U.S. Military Defense Energy Support Center. Okay? It's one of the first concrete examples that you can see of a good spin-off from the UAS efforts that you're seeing worldwide. So the U.S. military had a need to keep its UAVs flying. It was having problems with the 100LL and continues to have problems with 100LL with all the reasons we have problems with 100LL. Everything from toxicology to lead buildup in engines. Okay, they're having problems with motor gasoline for all the same reasons we have problems with motor gasoline, which is the variability of that fuel, especially in countries where you don't have good fuel supplies. So step one is that it's an ASTM spec, largely brought on by a spin-off from the Defense Initiative on the UAVs. Point two, the ASTM specification makes this a commodity fuel. It is a broadly based specification. The UL 91, as an ASTM spec, is 100LL minus the lead, minus the touch off the lead. It can basically be produced by any refiner producing 100LL today. Why is that important? If you want low fuel costs, you drive it towards a commodity. The consumer in these items are best served by having commodity fuels to keep their costs down and their operating costs. So long term, you do want to have a commodity fuel to keep those operating costs down. Point three, UL 91 allows us to get a jump on the other development that's needed to roll out the unleaded avgas. So rolling out an unleaded avgas is going to have a big effect on lubricants specifically. Right now, the lubricants that you use in your engines are formulated to handle lead. So there's chemicals that are in your oil today, which when that lead is combusting, and I know the chemist is right here, so we're going to keep it at one level. So you basically have acid developing your lubricant today because you're burning leaded fuel. That acid, okay, is corroding your engines. When we move to the point of getting the lead out of the fuel, we're going to be in a better state to move the lubricants and improve corrosion protection. Most of us, if we admit it, if we admit most of what the consumers are doing, they're not getting their engines at TBO, they're timing out in terms of years, and one of the biggest issues that we see as engine service providers is corrosion. So it's a big deal in terms of where we move on lubricants. And Lycoming is collaborating with both Shell and Total on a fleet operator based in the UK to be able to take a close look at what we can do to move lubricants forward. Fourth, and very important, a regulatory agency, meaning EASA, okay, in a guidance document basically approve the fleet of aircraft for use on a fuel without an STC at the airframe level and without action by the type certificate holder. So for this very well-conditioned UL91 avgas, unleaded avgas, EASA issued the guidance that without STCs, without type certificate holder action, those aircraft are now approved for use. So there's four very big elements there, okay, that we chip off the block and we use as a roadmap going forward for a total unleaded avgas solution. So the bottom line, it's a logical step towards UL 100. It's an immediate benefit to users in some parts of the world. No, you will not find UL 91 produced or distributed in the U.S. today. It's not available today, but it is available in Europe, and it's driven for some very different economic reasons in Europe. We're not in favor of pushing UL 91 up to UL 94. That'll move a commodity at a fairly low cost into something that's more expensive. Okay? Our service instruction on this one is going to issue this fall, which is going to list the next series of engines on it. This will be Lycoming 1070 Sierra version, SAM version. That'll list the additional models, and UL 100 remains the objective. So on this topic, I'll be doing another fuels forum presentation tomorrow at 2:30 in the Honda Generator Pavilion. I'll be covering a little bit of our Lycoming's perspective on the ARC proceedings. I'll be covering some of the UL 91 in more detail and the steps forward on that. So we're also going to be recording that on video camera and trying to YouTube it on the Lycoming channel. Fingers crossed that the technology works and the background noise is low enough to hear. So next up is the IE2, the electronic engine. The IE2 engine remains Lycoming's flagship technology program. If you remember last year, we disclosed that the IE2 was selected to power the Northrop Grumman Firebird. Northrop Grumman Firebird is an optionally piloted vehicle. It is an intelligence, surveillance, and reconnaissance platform made by Northrop Grumman, obviously for DoD applications. With the IE2 powering that aircraft, they achieved 100% availability in the DoD-sponsored Empire Challenge in 2011. The IE2 technology was selected by Northrop Grumman to power it's really a multi-million ISR platform because of some very unique elements which is offered in the IE2. We had not disclosed those before, but today we're going to give those a little bit more detail. Specifically, the IE2 feature set that was opened up for Northrop Grumman Firebird includes an anti-detonation injection system which allows attainment of full takeoff power on lower octane fuel. It includes an operator selectable multi-mode, multi-map, which allows the engine actually to change its behavior in operation, and on the Firebird they can actually change that behavior while they're in flight. And of course, our computer talks to their computer, so in that environment you actually have the flight control computer talking to the engine. So you actually have a complete autopilot with the capability to actually land it. So you close the loop, and when the pilot is not in the loop on that aircraft, they literally do push the button, find the runway, and it brings the aircraft back home. So you have throttle control coupled with navigational control on the aircraft. And that feature set are three important features that are in the IE2. Now, are you going to see that in a certified aircraft in the next year or two? No. Okay, this is a company and application that has larger resources than the average general aviation manufacturer, but it is representative of the technology that we've included in the IE2 and the feature set that we see eventually making its way to certified aircraft. So it remains a full go project. It is fully transitioned to FAA experimental commercial production in 2012, and Part 33 is in its final stages. So this time right now, I've got time for some Q&A. No questions? So I'm still writing? Oh.
But the other question was on the AEI. You said you don't see it migrating to commercial aircraft in the near future, but beyond that, do you see it as practical?
The question was in terms of the anti-detonation injection system. In the immediate future, we don't see it on general aviation or certified general aviation aircraft, but do we see it in the future? Yes. It's an item that You need aircraft systems to be able to get the ADI to work, and all those systems are being incorporated in Firebird on that front. It is a feature set that we're not certifying in the current version of the software for the certified engine, but that feature set will be rolled in different block changes and system changes that you have on it. So everything that we're doing for Firebird has a roadmap into a general aviation application. It's just not in the immediate product offering for general aviation now.
If you look further down, do you think ADI in general has the potential market horsepower to be a solution in blue 100 UL or is it 100 UL?
The question was, do we think ADI has the potential to be the alternate solution to UL 100? You've got a huge number of aircraft out there. Doing an engine retrofit, an ADI system retrofit on 200,000 aircraft, we can argue how many actually need $100, stuff like that. So you can do it on 50,000 aircraft. You're talking about a full engine STC, and those aren't cheap pennies. So from that standpoint, there's a long legs left to the UL 100 solution. Is this a technology that rolling out today that you could use? Certainly. But once again, 100 years of production to replace the existing fleet. You need to satisfy the existing fleet need. There's lots of technology that we can throw at the solution, much of which could be very expensive for the consumer, and we need to be cognizant that if you make it too expensive for the consumer, they're just not going to fly. That's the reality. Steve?
Yeah, can you tell me what the horsepower output was with the ADI and that EI2 engine?
Your question was, what was the horsepower output with the anti-detonation injection on that engine? Okay, so it was flying. I can give you some background. The fundamentals of that system were worked out in John Sharp's machine on the NXT. And, okay, so take your Malibu engine and double it. Okay, in terms of this standpoint, the real question would be is, can you make up for the decrease in octane of anything that we would see coming? A worst case scenario, could ADI make up for that? The answer is yes. Any other questions?
Is there any research or plans to use the compression ignition or the diesel technology as some of the other EAA manufacturers using or researching?
The question was, is there any self-ignition or compression ignition or diesel cycle engine items? Yeah, Lycoming's done 4 of those 4 diesel programs. We haven't brought our particular programs to market on it, but that technology exists. Once again, it's for some users, okay, it's a very appropriate technology. When you can't get gasoline, period, of any type, okay? Some aircraft, it's a very good solution in some cases on that front. Lycoming doesn't have a diesel product for the general aviation market today, but that's certainly technology that we're familiar with. And we're also cognizant that just like if you buy a truck today in the U.S., you can choose diesel, you can choose gasoline. To a large extent, whether it's a good solution for you depends on what are you doing with that vehicle. Okay? And the same thing will come to play in terms of the diesel cycle engine burning jet fuel, because that's what we're talking about, a diesel cycle engine burning jet fuel, not diesel engine burning diesel fuel. Okay, diesel engine burning jet fuel in aviation, what is your mission, okay, and what's the right thing for you to choose in terms of propulsion for that mission? Any other questions?
One more. You got any traction on the OEM for the IE2 engine?
Any traction on the OEM for the IE2 engine? For the certified version, we can't disclose those. For the experimental, obviously there's Lancer and there's Northrop Grumman. I'm sure if you'd like to buy one from Northrop Grumman, they'd be willing to sell you one. Maybe